Serverless processing for big data. Why big data? Basically, big data, when we talk in big data, the first process engines we think is SQL, the most common language I think everyone knows in data world, and Spark. Flink is also important, but this is for stream data. So this is, in my from experience, it's different to see those scenarios in real life. Most of the time it's batch processing or mini batch processing. That's the reason most of the time we focus on SQL or Spark processing. How does it work? Very, very easy. Number one, you need to have resources. Number two, once you have the resources, you create your jobs, the execution or the running code. So those are those two steps. Number one, create the resources to execute the processing. Number two, configure the execution. I mean the code itself, the Python code, or Scala code, Java code, whatever. Okay, how the resources work? Basically, when you go to this part, resources, resource pool, you go to the void resources pool, and you will have two options, pay-per-use or monthly. I think if we were talking pure serverless, I think the most common is pay-per-use because you create the resources, use it, and delete. You don't need to manage any platform or to install some extra things. Okay, important. Yes, the resources you can, the most basic one is 16 CUH computing unit hour. It's like this smart processing. Every CPU is one vCPU, 4 gigas of RAM. It's a very, very basic unit. I mean, this is especially for parallel processing, or you can scale up to how many nodes? This number of nodes, so you can have a very, very, very processing, parallel processing. Okay, yes. Okay, this is the first one. How do you have your resources? Basically, you do pi. Say you set the size of how many resources you will have, and basically that's all. At the end, you will have something like this. For example, this resource that is for this demo account is this one, that is 32 CUs computing units. How can you use this? Basically, you will manage your queues. At the end, the queues are the one that will execute the processing. There is for general purpose and for SQL. So if you want to do SQL execution, I mean select, start from, blah, 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 SQL language, you need to use a queue that is configured for SQL. If you want to use Spark or Flink, you need to use a queue that is for general purpose. So this is important because once you set one queue or one resource for SQL, it's only for SQL. Once you set a resource for general purpose, it's only for Spark or for Splink. They have different engines, so they need different resources. Once you have configured your queues here, you will see them there. So once you see there in this section your queue that is available, I mean, for example, the general purpose, this one, and this one for SQL, this is also important. The complete resource pool is 32 CUs. So in this demo, the half of them is for big data, is for Spark, the general purpose. I mean, this one, and the other half is for SQL. So you can split in different queues your resources. So this is important because if you want to execute in parallel different process, you need to create different queues and you need to segment or divide your complete resource pools in different queues. Okay, this is the first step. First step, create your resources and your queues. Once you have your queues here, I mean ready to use, you can start configure your process. How does it work? Very, very, very easy. Only you say create job here, upload your code, do execute, and that's all. Basically the main idea here is you upload your code to OBS in one specific bucket, and basically that's the idea. And you need to fill this formulary, but most of them are optional. Number one is the queues. Who is going to execute the computer power? Is already we saw in some minutes ago. The Spark version, this is also important. If you want to execute another Spark version, you need to open one ticket so you can make available that Spark version for the execution with the technical support. So you say my Spark version is 2.7.3. You open the ticket and they will open in your account this specific Spark version in case of compatibility issues. Okay, this is the first step to configure. Who is going to execute the queues, the Spark version? And here is the one where you go for the code. So for example, if your Python code is here in hello world.py, like this one, you only upload your code here from OBS, and that's all that you need to execute. You only need the queue, the resources, the code, and the other one are optional. For example, you have some dependencies. Example, you want to read some XML files using Databricks library. You can load the Databricks library here, and for the dependencies, the .jar or pipe files, another dependency from Python. I mean, this is optional because are the dependencies. If your code is pretty simple, like hello world, you don't need dependencies. And about settings, you want to tuning the execution. I mean, how many memories per executor, how many cores, how many RAM, how many memory for execution for the drivers. I mean, you can tune the resources in this part, and that's all you need. Basically, the summary. Set the resources that you already purchased. Load your code. Here can be a hello world.py, the Python file. Maybe some job configuration like Spark argument or dependencies. This is optional. And also, if you want to enhance some execution or optimize the execution, you here can configure that part. And that's all. Mandatory is the resources and the codes. With this only two, you can execute. Click here, and they will send you directly to this part that you will see the complete summary of the configuration. I mean, which Spark version, what is some arguments. Well, this is for parameters of the Python. The code itself. I mean, you will see the configuration of the execution, how many cores, blah, 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 how many memory. And the status is already here. So for example, if you click here, the Spark UI, you will see the Spark interface about the execution of the process. It's yes. For example, you will see the detail plan about the execution of the stages. I mean, this is Spark. So this is for another session if we're talking about Spark especially. But the idea is that one. You can monitor the execution from here using the Spark interface, and the job, states, environment, executor, all the details about the Spark processing. I mean, parallel processing in general. How many cores are active, blah, blah, blah. How many are dead in general. You will see that you can monitor your resources of the execution here. And also, if you want to see more details about the logs, you can click here, logs, and you have access to the logs about the execution. I mean, or the Spark processing, you will see here. Basically, this is important. Logs are stored also in the OBS. So for DLI, all data is in the OBS. Code is in the OBS. Input data and output data should be in the OBS. And logs are also in the OBS. I mean, of course, you can create some connections to databases or to data warehouse, but I think the most common scenario is to process data directly from the OBS. Here, you can see the logs in general. Just to show you, STDO log. And that was a 10-minute review about the DLI. I don't know if you have any question because I think we're done for this session. Sorry for taking much more time than it should be. But I want to close this session with the ideas, the main ideas. Number one is basically we have capabilities like other vendors, so I think it's very important. If we don't have it, we need to raise a ticket and ask for support. But the idea is that we can do what other cloud providers can do, talking about data. That this is this topic. Number one, all the services has many functionalities. So if you want to check something in special, for example, you say, I want to process, I don't know, JSON files using Spark SQL execution in DLI serverless, blah blah blah. We can check it later, no problem. We're always here to support. That's our job basically.